GATE 2014 Civil Engineering Set 2 Question 49. A wastewater stream of flow 2 meter cube per second and ultimate BOD of 90 milligram per liter is joining a small river with a flow of 12 meter cube per second and ultimate BOD of 5 mg per liter. Both water streams get mixed up instantaneously. Cross-sectional area of the river is 50 meter square. Assuming the deoxygenation rate constant K as 0.25 per day, the BOD in milligram per liter of the river water 10 km downstream of the mixing point is. The relevant NPTEL reference has been mentioned along with the 4 options. So coming to the useful data, if we have a river stream which has a certain discharge QR and a certain BOD level BOD R, assuming a wastewater stream from a sewage comes into the river and gets deposited, so there will be a mixing that will take place. So assuming the wastewater had a discharge of QW and a BOD as BODW, so the BOD of the mixture of the sewage and the river would be equal to the BOD of river into the discharge of river plus the discharge of wastewater into BOD of wastewater divided by the total discharge, that is QR plus QW. Once this is known, this BOD would reduce in the river due to the biological decomposition process. So the BOD level at a time instant t will be L0 e power minus kt, where L0 will be the initial BOD of the mix, and depending upon the constant k and the time taken for traveling to a certain place, the BOD level would decrease to a level of LT. So 1 and 2 would be used in solving this problem. The discharge in the wastewater is mentioned as 2 meter cube per second. The BOD of wastewater is given as 90 milligrams per liter. The discharge in the river is given as 12 meter cube per second, and the BOD in the river is given as 5 milligrams per liter. So using this we would find the BOD of the mix. So that would be equal to QW into the BOD in the wastewater plus QR into the BOD in the river divided by the total discharge, that is QW plus QR. So this would become 2 into 90 plus 12 into 5 divided by 14, which would be 240 divided by 14, which becomes 17.14 milligrams per liter. Now we need to find the speed of flow, so that would be Q by A. So Q is equal to 14 meter cube per second and area is given as 50 square meters. So we will divide this by 50. That would give the value as 0.28 meter per second, which is the speed of flow. Now we will find the required time. So that would be L by V. So L here is 10 into 10 cube divided by the speed, that is 0.28. This value would come around 35714.28 seconds. When converted to days by dividing by 86,400, it would come out to be around 0.41 days. Now the BOD level LT would be equal to L0 e power minus kt, where L0 is the BOD of the mix, that will be 17.14 into e power minus k value has been given as 0.25 into 0.41. This would become 15.47 milligrams per liter. So the BOD of the river water 10 km downstream of the mixing point is 15.46, that is option C. The relevant NPTEL reference has been listed.